statements, and we've gone through a lot of stuff, but really sort of the question is, thanks, Dr. Anderson, greatly appreciate that. Is this stuff useful? Can I actually do anything with Python? That's a fair and valid question. So let's see if we can tackle that one. Okay? So, one thing that we actually haven't talked about is sort of like, what happens if I have a really big Python program? Pretty much all the programs that you've developed in this class have all fit into a single file. Right? Homework 1 through homework 4. It's a single file. Everything is there. If I want to see what your code looks like, I look like in a single file and I'm good to go. If you were doing a real-world Python programming type of thing, probably would not fit in a single file. Because first off, it's huge, right? There'd be a lot of stuff going on there. So you use something called modules. Okay? So what's a module? Well, it's actually pretty simple. So let's say that the majority of your program, or really the key main part of it, we stick in a program called main. But how if we took all those functions, you know about functions, right? All those functions, we pull them out and put them in a separate file called extras. The interesting question is how could the main part of your program reach out and grab extras? Because now you've got two separate files that have all the code that make your one program. And basically, that, in a nutshell, is exactly what a module is. Well, good news, because there's a statement in Python called import. And it tells Python to include the extras file into your program. From that point on, you can use the modules functions as if they were entered directly into your program, right? Well, cool. Let's take a look and see what this looks like if we whip up some code to do it. All right, so what do we have here? Well, this is from homework number 3. Okay, so this is cool. You recognize all this stuff. We're very, very familiar with this. Okay, but what's missing from homework number 3, interestingly enough, is all those functions that we had there. So what were those functions? Go ahead and open up another file. The top called extras. Oh, look, extras. There it is. So we created this other file called extras. What's an extras? Well, encrypt social security number, the function. Let's see, decrypt social security numbers, the function. And scan. Remember scan, where we're looking for invalid social security numbers? So that function is here also. And that's it. So this file extra just contains 3 functions, and that's it. Can we run it? Well, yeah, we could run it. Would it do anything? Absolutely not. It's just a function, right? We don't call it a function. So we actually have to go back to the other program, our main program, if you will. And what we've got going on here, so we recognize all that sort of stuff. What we're really talking about is this magical phrase here, where we import extras. So what we're going to do is we're going to reach out to that extras file that has all of our functions in it, and we're going to bring all that code into our main program, and then we're going to run, and we're going to use our functions. Shall we do that? Seems like pretty simple stuff. So we'll just run it and see what happens. Well, that was wickedly successful, wasn't it? No. What's it telling us here? So problems, print, and then all this there's a print patient, that print patient name, encrypt SS, decrypt SS. Okay, so we're making, and then encrypt SS. So we're making function calls in the statement. And it says name error. Name encrypt SS is not defined. But didn't we import it? Right? We had an import statement, right? Should we go back and look at our import statement? I mean, I'm pretty sure it's there, wasn't it? Import extras. And we saw that we had all listing all our functions and extras. We brought it in, and we ran it, and we got a big error message flying. What did we do wrong? Well, we didn't do anything wrong. Why is Python broken? Python hates us. Yes, I think we can prove that. has dealings to.
Is there something in your other code that's broken? Is there a part in broken?
Yeah, we're talking about something called namespaces. Okay? So all code in Python is associated with something called a namespace. Now, coding your main Python program and with an idle, so pretty much all the stuff that you've been running to date, is associated with a namespace called underscore underscore main underscore underscore. Okay? Basically, that is the environment in which your code is running. Now, what happens is when you put your code into its own module, Python automatically creates a namespace with the same name as your module. Okay, so we stuck all of our functions in a file called what? So that means it created a brand new environment called underscore underscore extras underscore underscore. And never shall the two meet. So we got main over here and we got extras over here. So we sucked in extras, yay, that was good. Now they're all hanging out over here, and we try and reference them. It says, I don't, in main, I don't know anything called. So the code in your module is associated with a namespace called really underscore underscore extras. All right, so we got a little problem. We got to find a make a bridge between these worlds, right? So when you want to refer to some functionality, you need to quantify the invocation of the function, which is a big adult way of saying you got to do something extra to reference it. Here's how it works. So right now the statement is encrypt, patient identity, all that sort of stuff like that. We've got to change that to here comes, extras dot encrypted. So we got to specify the namespace, and then we have to specify the function. Make sense? I mean, just Python saying, so where is that function? And we say, well, it's over in that namespace. Oh, okay. And then I'll know where to go. That way the Python interpreter knows where to look. Format for namespace qualifications is the same as the module's name, followed by a period, and then that's the function's name. So let's take a look at it and figure out how that one works. What am I going to call this? Alright, so what do we got here? So we got our buddy Mr. Import extras. Let's figure out, okay, so this is where we have problems. So print patients.eating place, oh my god, we have to keep going. Okay. They don't think there's any way to scroll to the right. That's my problem. Or just backslash. Wrong line. Alright, this will do it. So here you go. A bunch of patient name stuff. We come down here. Extras dot decrypt SS. Extras dot decrypt SSS. So we're putting the namespace before the function that we call. We're saying now we can import it from another file. As long as we put that there, it should work perfectly, right? So let's give it a run and see how it goes. What was that? Homework number 3, I think we're doing here? Okay. Woohoo! Scan SS, power drops out. We know what that problem is though, right? But this part seems to work, right? Cool. All right.
So you can change extras to whatever you like. Import.
Yeah. So extras in this case is just the file name that I imported it from, right? And that defined the namespace.
You got students in there.
Yeah. So if you wanted to, like, you just have one code functions.
I could have functions. I could have, science. I could have math. Which, and I appreciate you bringing that up. Well, I'm actually going to talk about that in just a minute. Exactly right. So, was there a question about my fantastic output here? This is cool. Everything good?
I just didn't work.
Yeah, no, I just didn't. I don't think it was.
It's just that I was supposed to be computer.
Now,
we create a program.
There is another way to go about doing what we just did. Okay, so what we just talked about worked perfectly fine and wonderful and stuff like that. But here, if you do from extras, import, and then you call out the specific function names, then what happens is that the functions that you call out specifically, you can just use as you used to use them, right? So you don't have to put extras dots in front of them. Because you called them out specifically as coming from that file, Python's smart enough to know that every time you see this, it's really extras dot decrypt, okay? You do have to be a little bit careful, because if you already had a function called decrypt.ss, when you pulled this little stunt, you would stomp on it. Your local version would go away, right? But that's not a big deal whatsoever. So let's see what that would actually look like. Okay. From extras, import decrypt SSS, encrypt SS, and scan SS. It's all three of them. Then we do page ID, and look, it's encrypt SS just like we used to use it back in homework 3. We didn't make any changes. We don't have to put extras in front of it or anything like that. Shall we give it a run and see if it works? So not only did it run perfectly, but also remember the other one that was having a problem now no longer has a problem because we didn't have to actually put extras dot in front of it. So we're all squared away there. Look at that. How cool is that?
Instead of importing the extras and trying to deal with it from inside there, we just import from the extras.
Yeah, so we got two choices. This is a good way to say it. So first off, we do import extras. Fantastic. It sucks everything that extras in. But then every time we use something that we got from extras, we have to put extras dot and then the function name, okay? Alternatively, we can say import from extras, but then we have to call out each and every one of the functions that we plan on using. When we do that, then we can use them just as they are, and we don't have to put extras dot in front of them. Fine. Make sense? What does Python look for? Where does it look when it wants to import files? Where on your hard drive? Well, if you type into Eric, import sys:/sys path, what Eric is going to tell you is that it's looking in the directory that it normally looks in, okay? And it's looking in another one called lib, idle lib, and it's looking in another one called Python 34zip, and it's looking in another one called Python 34lib, and it's looking in another one called site packages, right? So those are the, what, five subdirectories that it will go looking for the file that you're trying to bring in. Clearly, it's going to look for your stuff first, but then it also has a bunch of things that it already knows about as far as packages you can include, right? Now the world has lots and lots of packages in it. It may actually be located someplace else. But this is where it's going to go right back. So if there's any default libraries that you want to bring in and it already knows about it, it will probably find. Okay, libraries. What kind of libraries are available to Python? And the answer is everything. Yes, sir.
That says system 32. You got a system 64, but it's also.
You know, that's a good point. I don't think so, because I'm thinking back to when I installed Python. I don't think it had a 64-bit option. I think it had a Windows and a Mac option, if I recall correctly, maybe even a Linux option, but it didn't actually have a 64-bit option for Windows. The answer is yes, of course, if there was such a thing, but I don't remember there being a 64-bit option for Python.
Right, no, I just asked that in case they were on.
If they did that, then yes, 100% agree with that. That 32 would probably change to 64. Yes, sir?
Would you just specify the directory that you wanted to look for? Or
Yeah, I believe so, yes.
We can like specify the path.
You have to, so it would be quote C:\\\. Remember, you have to double all your slashes, right? Slash. But then I think you can specify exactly where that file is located. So we did import extras. Now the trick on that one was my extras was located in my default subdirectory where my code was located, right? So I didn't have to specify a path name. If it was located in a different subdirectory, I think I would have had to specify a path name and then the file name. Does that make sense?
And then already, like, if you have like two text files, like you have your text file and your code, it automatically falls to like in the same file.
Yeah. Yes. So Eric, the interpreter, assumes that the file that you're talking about by default is in the same directory that your code is in, right? Because that's where it looks for right after that. If it's someplace else, then you have to specify a path. Does that make sense? Yeah. Libraries. What do we got going on here? We got libraries going on already. So first off, what can you get libraries to do with Python? Now, what are libraries? Libraries are functions that somebody else wrote for you. Okay? Using the fabulous and wonderful import command, you can bring them into any Python program that you write. Oh gosh, what kind of libraries are there? Cryptography, database, game development, GUI interfaces, of course, audio and music, image manipulation, interfaces to Java code, networking, plotting, presentation, scientific, web development, HTML, forms and parsers, workflows, editorial notes, whatever the heck that is. But yeah, the universe is about this big, and people have written Python programs to do everything, right? And they're out there, and using import, you can bring them into a program that you have written, so you don't have to write their code. You can just use their code as a part of your program. This was, I think, PolySci, which contains NumPoly, SciPoly Library, Fundamental Library for Scientific Computing, Matplotlib, two-dimensional presentation, something called Pandas for data structures and analysis, Simple Mathematics, and then IPython, which is Enhanced Interactive Console. So all of these are included in one particular library that you can draw in. And then once you do that, you have access to all those functions. You can do anything you want, right? So you do SciPoly and then specify the functions. Right? So there's no need to repeat or create code that somebody else has already created for you. I'll bet you out that there's someplace there's a bubble sort. Oh, we'll talk about that now. There is vision. There is. I mean, there's a ton of that out there, obviously. Right? We might. Or something close. How about something close? Maybe not tickle itself. So let's talk about this. So let's use your Python to do something, your Python skills to do something useful, shall we? So, from homework number 3, you'll remember this. Homework number 3, this is just a little trip down memory lane. U.S. government asking the hospital to report on exactly who it's providing medical services to, create a report that lists all the cities that patients live in, and provide a count for each city of how many patients come from that city. Print this list out in alpha order. How did you solve this part of the homework? Did you write a lot of code for that?
Let's get a room.
Okay.
So I would say that your code looks something like this. So build a list that contains each one of the different cities that the people live in. So you went through and you found the unique cities. For city step in list of cities. If the current city name has already been used, then add it to the list. If not, throw it away. Print out the unique number of city names. Then you did like a bubble sort on the number of cities. And then you probably what, like printed it out? I think that's almost right. Yeah, so you just do some printing at the end. Let's see what this actually looks like. Woohoo! Adding city Lakeland, adding city Orlando, adding city Tampa. So those were unique ones that you found. Number of city names is 3, and how many people there are 6, 5, and 4. So I mean that was code that you did for homework number 3. It's perfectly good code, right? But now that you're smarter and brighter than when you did homework number 3, maybe we could do a better job of that, right? There's no question that it works, so we're not going to tell you about that. We're just saying that we think you can do it better. So what did you actually have to do in this part of the homework? Well, very right off the bat, create a list of unique cities that people came from, and sort the city names into alpha order. All right, well that was reasonable. But you know what you didn't know at that time is that you could use stacks, right? And what's the magical thing about sets? No duplicates in sets, right? So you went through a lot of coding effort to make sure that you only added a unique name to that list that you were building, right? And in sets, do you give a darn? Just throw the city name into the set, right? And let sets worry about whether or not it's unique or not, right? And then it says count the number of people from each city. So what are you going to have? You're going to have a city name and a count, right? That sounds like a key and a value, doesn't it? And when we talked about dictionaries, didn't we say dictionaries were all about keys and values? Maybe we could use a dictionary to do that part. Because the alternative way is that you have a list that has the city names, and then you have like, what, another list that has the count of people, and there's no connection between those two lists, right? Right. But if we use a dictionary, there'd actually be an association between them. And if we found the key, then we can find the value. Okay, well, let's see what we can do here. So right off the bat, wow, that looks like a lot less code. So let's see what's going on here. So create a report that lists all the cities that the patients live in, find them from this list, turn it out in alphabetical order. So city set is a set that has nothing in it. So it's an empty set. Build the list that contains each of the different cities that the current set of patients lives in. Remember, that was a chunk of code. If we checked to make sure that we didn't add the same city name a couple times, hey, we're using sets. So for patient ID in range, length of patients, so basically run through all the patient records, city set, add patients, square patient ID, item number 4, which I believe is the city name, right? So we're basically grabbing the city name and throwing it into the set called city set, and that's it. We're not looking at it, we're not checking it, we're not trying to see if there's a duplicate. We say screw it, just throw all the city names into the set, right? And then what do? Print the number of unique city names, length of the set city set. How many names are in there? Okay? Then we come down here and we say print for city name in sorted city set, print basically the city name. So now we're even sorting it. We're using one, so forget the bubble sort stuff, screw that. We're going to use Python's sorted command and poof, get it all sorted. So let's see what this does. Woohoo! Number of unique city names, 3, which is good, because that's what we did up here. Then city name, Lakeland, Orlando, and Tampa. Lakeland, Orlando, and Tampa. Okay. So that seemed to work out pretty well, didn't it? We're only really sort of missing one thing. What's that? Number of patients. All right. So maybe make another run at this and see if we can add the ability to track the number of people who live in each one of those places. That code can't be that complex, can it? We added some more code, but not a lot. Okay, so all this stuff is what we saw last time. We made a set, we threw all the city names in. Okay, that's how this thing starts to change. City dictionary equals squiggly bracket, which means we now have an empty dictionary, nothing in the dictionary. Okay, that's cool. Got no problems with that. For city name in city set, which remember we created here, city dictionary, city name equals 0. So it looks like what we're doing is we're initializing the dictionary. We're putting all of the individual city names in there. And how many city names are there? 3. And we're giving each one of those keys an initial value of 0. Okay, so nobody lives in the city is what I'm saying. Okay, cool. Now what do? Well, for patient ID in all the patients, so we're going to run through every single city, okay? City dictionary, patients, patient ID, 4 plus equals 1. So we're going to look into the dictionary. We're going to look for the city, which is the key value, and then we're going to find it, and we're going to increment its value by 1. Okay. Shucks, that's just 2 lines of code. And then we're going to print it all out. So sort of 2 lines of code to figure out what cities we got, and 2 lines of code to basically figure out how many people are living there and how we're done. Fundamentally. Now the interesting thing here is that we're not doing any checking to make sure that the city's in there, right? Because things can crap out on you really quickly with the dictionary. So why aren't we checking? Why are we checking to see if the city is in the dictionary before we pull it out?
Are we already adding them to the dictionary?
Right. So the concept is every unique city name in our customer is in that set, and we've added it to the dictionary. So we're reasonably confident that as we go through our dictionary, as we go through our customer list, every single city that anybody can live in will be in the dictionary. Right. Otherwise, we have to do some clever trapping and stuff. Woohoo! Unique cities is 3, Lakeland, Orlando, Tampa, 654. 654, that's exactly what we had previously, right? Ha, diggity, this Python stuff is awfully cool. All right, so I got one more real-world Python challenge for you. And actually, this is something that came across my desk probably about a month ago at this particular point in time. So I'm working with the Hillsborough County PTA organization. And the PTA, the headquarters for the PTA in Hillsborough County, charges all the individual PTA units a fee each year to be a PTA. No big deal whatsoever. But they have to create invoices for each one of their units. And I think they have 214 individual units. Okay? For whatever reason, their program that keeps track of this stuff produces a single file that has invoices in it, right? I guess it'd probably be okay if you were printing it out, right? Because it would print out an invoice on each sheet of paper. And God's honest truth, I think that is actually what they do right now. They print it out, they have 214 pieces of paper, and then they figure out what goes where, and they ship it off to each one of the individual ones. Well, we set up a brand new website for them, and we said, well, it'd be great if we could put our invoices on the website. And right then, all they had was one big file that had all 214. So I guess if you go find yours and then print it out, and then we said, there's got to be a better way. How about if we parse that single file and we produce 214 individual files that have the receipts? And the answer is, yeah, let's do that. Well, we've got mad Python skills, right? We should be able to do this, right? Okay? So we want to be able to process the file and create 197 or 214, whatever it is, with one invoice per file. Now here's the other trigger. Include the local unit name, Smith High School, Sickles High School, whatever, in the file name, right? Because we're going to produce a zillion files, so we want to make sure that the file name actually says which PTA unit it belongs to. So let's take a look and see what we're actually dealing with here. So let's take a look at this big honkin' So this is what an invoice looks like. Okay, Hillsborough County Council of PTA, they've got their address, they've got the invoice over there, we've got a date, to Adams Middle PTSA, so this is the school name. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that. 8 or 9 lines in, we bump into this. It's got a 2 TO colon at the beginning of it, so we can be able to find it. And then it's got a bunch of stuff going down. but pretty much just one sheet of paper. We hit the bottom where it says date received, amount paid, check 2. And then you can see that we start to hit the second invoice, right? So we've got this file that has 197 or 214 of these in it, okay? Just one big continuous text file. What we'd like to do with our Python code is go through there and slice each one of those out, create a unique file, and stick it in it and give it the right file name. Tiny little bit of code, just to make sure that we're going to dip our big toe in the pond, shall we? Let's just open up the file and print out the first 10 lines. Okay, we'll just sort of see what we got there. So what are we doing here? Invoice file name equals blah 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 blah, and that's the name of the file. Invoice file name open. Invoice file name R for read for index in range 0 through 10, which we know those functions we covered through the last line. Print invoice file dot read line. So real simple code, we're going to open up the file that contains all 197 invoices, and we're going to read the first 10 lines and we're going to print it out. Can't get any simpler than that, right? Let's give it a shot. Do that. Oh, man. That didn't work out so well. I mean, it's only a couple lines of code. What's going on here?
Search file.
Bio not found error.
Is your code the same as our here?
Which one? It says, or no? It says,
Well, that's actually interesting. I wasn't expecting that.
yeah, Aaron. I don't know what it's
Maybe you overcoded that. Excuse me, coding guys, we coded the code program wrong.
Maybe I need to take a look at my files and see what the story is. Hang on just a second.
Companies like Microsoft and big companies, do they pay if you find a bug, you can fix it yourself?
So it'd be considered a bounty. And you can't fix it yourself because it's their code.
Right.
But if you find something, generally what they're paying for is security holes. If you discover that you can do something with their program that you should not be able to do, and you report it to them. If they have a bounty program in place, Mozilla has one, Microsoft has one, I think Google has actually one of the more profitable ones, right? Something like that. So yes, they will actually pay for that stuff.
I mean, yeah, essentially, because you have an actual thing, you just say, this breaks. Right. Yeah, I didn't even think of that. Yeah, I did not know that. That makes sense. Like, okay, you're just to go around certain functions. But see, I feel like even then, if you're not using it daily, you have to find the process. As opposed to you and I, where we're using it on a daily basis. Okay, so. Yeah, if you consider the skill, take more than half an hour.
We all need to post this on program, or like, what you should do is you should like get some white like paint or
Someone was
something.
saying I should like shave the stashes, so it said my name in there.
Banjo. Yeah, he's sick.
Oh.
Or AWOL, whichever one works.
Hey, do we have a subreddit for our school yet? Yeah. Yeah, we did.
It's a subreddit.
Subreddit?
Yeah.
It's like Reddit, but
You know what Reddit is?
No.
just a
Okay.
troll. It's a troll website.
It's not
Is it-
true.
Tell me I'm wrong.
What did you say?
Reddit?
Yeah, what about it?
It's a troll site.
Oh, what's that?
No, not necessarily.
Right.
Not necessarily.
For the most part.
Some subreddits.
So it's just Facebook, not every one.
That's also
Is it like, yeah,
No,
no.
nothing like that.
Kind of like.
So it's not enough.
I mean, it's just some sort of different.
I don't see a social media.
Spear, the spear.
There's not like a name connected in it, but it's just kind of exciting.
Florida Polytechnic can still choose. Yeah, but that's
No,
not
but it's
official.
not Facebook, where
Oh,
you're like,
yeah.
hey, here
I
I'm
always
saying,
thought
it's
someone was
just like
like-
your username.
Yeah.
I don't think
I think when you go away, it counts on the road. Oh, no, this is great.
It's amazing. I love it.
That one.
What's that one? It's a tournament for here this morning. How about that? I was really
What is this? I love this too. I'll have to start checking out the suburbs now.
Ah! So I have no idea what I did wrong. But that's okay. Because I've now fixed it. I told it where the file is.
You fixed it?
Oddly enough, it got
What, you
confused.
broke it?
I fixed it, so now it's not working correctly.
Oh.
So we have a different error message.
Yes.
What's this one? So it's running along. It gets confusing very quickly.
Our character map,
So we're saying print invoice file read line. So we sucked in that line from the invoice file, right? And now we're going to print it out. Okay, what it's telling us is codec can't decode byte 0x81 in position 18.
character map. It's an undefined character, I guess.
What's up with that? What's going on, I say? So here's the problem. Our good buddy, which is Microsoft Word, is a file that contains a lot of formatting commands in it, right? So it's got secret codes. It's non-text file, right? So what happens is that Python opens it up, reads some stuff, finds some weird characters right off the bat, things that don't fit into a traditional ASCII table. And it says, excuse me, something's horribly wrong here. Now, it turns out Python can read binary files, right? But you have to tell Python that it's going to be reading binary file. Otherwise, it's going to assume that it's reading a standard sort of ASCII text file. Obviously, in this case, it got surprised. It said, this sucks really, really bad. Okay? So what we need to do is we need to save that Microsoft Word file as a text file. Cool. All right. So then all we have to do is just save it as a text file, and we can run our program and maybe get that to work correctly. So let's give that a shot. So if you take a look at the code we have up here now, you'll see that it is exactly the same as the code we just took a look at. Pop open the file, open it up for a reading, and then we run through and print out just the first 10 lines. The only change is now we're bringing in a different file. We're bringing in the text file. So let's see how this one works. Woohoo! Did we get the first 10 lines of text? Cool, so we got down to actually one line beyond Adam's middle UTSA, right? So what do we know about what's going on here? Tons of spaces, all stuff like that. Okay, so first things first. Well, we've got a problem here. We're solving it, but we're making progress. Okay. We know we're going to have to pick off the individual school's name on the invoice. Remember, because what we want to do is we want to write out to a file that actually has the school's name. How do we deal with cover? We're going to use that to create the output file name. Name's located on the 8th line of text in the file. So we got to go down 8 lines, and then we'll get the school name. Now this poses a little bit of a problem for us. Why? Well, that's not even a big deal. But we're 8 lines down by the time we find something that we want. What about those other 7 lines? Are they important to us? Yeah, right? I mean, it's part of the invoice, right? So we go 8 down, but we have to save the first 7 someplace, right? Once we hit 8, we got the file name, we got the school name, we can build a file name, then we can open the file, right? But meanwhile, we have to have saved these other 7 lines, tucked them away someplace, okay? Then we got to write those 7 lines out, right? And then after that, we can keep writing until we hit the end of the invoice. How are we going to know we hit the end of the invoice? There's some sort of signature thing at the bottom, right? Like date or something like that, right? So if we find that, we should be good to go. So let's give this a shot. Okay. So let's see what we got going on here. Open up the file, open it up to read. Current line equals invoice read line. So we read one line, we stick it into this thing called current line. While current line not equal to quote, quote, why are we doing that?
If it's not equal to blank space.
Not equal to end of file. That's exactly right. So we have it at the bottom of the file. If 2TO colon in current line, local unit name equals current line strip TO colon. So what are we doing there? We're going to remove TO colon from the string that we brought in, right? Okay. Local unit name equals local unit name R strip, which actually strips off the stuff at the end, I believe.
On the right side.
And then local unit name dot strip /T, which I think gets rid of like tabs and stuff like that. Right? Okay. Print processing invoice for local unit name. Current line equals invoice file read line. So we're going to run through all the lines in the file, and we're going to pick out each and every one of the school names.
So since there's a right strip, there's left strip too, right?
Yep, that is exactly correct. Front of the line, end of the line. That's what it is. Make sense? So let's give this a shot and see how it goes. See if we can find the damn line. Something weird, man. Oh, I know what it is. Woohoo!
Yay!
So does it look like we reached in, we got each one of the school names? So we're successful there.
Oh, crap.
Fantastic. Now let's see if we take it to the next level here.
This is all real data.
Yeah,
should we be?
Yeah, next level.
We never saw that.
Alright, so this is sort of like all the code. Let's take a look and see what's going on here. So while line is not equal to the end of file, word list equals line.split. Remember, we sucked in one line, now we did a split on it, which breaks out each individual word on it and turns it into a list, right? If word list is not equal to an empty list, when would word list be equal to an empty list? Or no, if we brought in a what type of line? A blank line, right? No blank line, no word. Okay. So if we're not dealing with a blank line, then if looking for school is true, okay, so we have not gotten to the 8th line yet, okay, then Header is plus line. So header is where we're storing all the first 7 lines. It's just a string. Just going to store them all in a string, right? We'll take the current lines that we sucked in, stick it in the header. If word list, the very first position, 0, is equal to 2 colon, what do we know about that line? What's that 2 colon indicator of? The next thing after the 2 colon is going to be the school name, right? Okay? Print, found school name. Looking for school now means false because we've found the school. Okay, that's all cool. For I in range 1 to length of word list, remember we're on a very special line. It's the line that has the name of the school. It really only has 2 things on it. 2 and the name of the school, right? School name equals a blank space. School name plus word list I. So basically we're going to suck in each part of the school name. Johnson Elementary School, and we're going to put a space between each one of them, right? S equals list school name, okay? So we had a string, we turned that string into a list. Okay, that's cool, but it's getting a little bit weird here. Why are we doing that? For I in range 0 to length of S, which is the string, if SI equals backslash, we turn it to a dash. The reason that code's there is because there is a single school that has like Brown/Smith Elementary School. And so it's a school name that has a slash in the name. Can we make a file name that has a slash in it? Absolutely not. So this is a little bit of custom code because we had one file, one school that had a problem with this name. School name equals double quote join S. So we're going to convert the school name back into a string. We'll print the school name. School name equals dot, whatever the school name is, we're going to stick .txt on the end of it, because it's going to be a text file when we produce it. Out file, open, school name to write, print, header. Remember, header is the single string that we've stuck all basically 8 lines of the first text in the file in. So we just shoved it all out to the output file. Now we set header equal to the null string, so we'll be ready for the next school. Now, if we're not looking for the school, so if looking for school is false, which after we find the school is what it'll be every single time, we'll go down here and we'll just print the line that we read in out to the out file. So after that, we just print every single line that we have read in, kicking to the out file. Now, if word list 0 is equal to date, we're looking at the very first word on the line, and if it says date, we know that we're at the bottom of the invoice, right? So we'll say print school name, print PTA invoice, print end page. So basically they're giving us status information. Looking for school is equal to true, because now we're going to start looking for the next school as it goes to the invoice. We're going to say out file close, and then we're going to look and we're going to read the next line coming in. So there's no real science going on here. Let's give it a shot and see if it works. Oh wait, I know this. Got one problem now. So we got that here. Found school name, PTA invoice, Leonard High School, PTSA, PTA invoice, Leonard High School, PTSA.txt, which is the name of the file that we built. And then we said end page, which means we're at the end of it. So basically we went ahead and produced output files for each one of these. Do a quick double check to make sure we did it successfully. Just do a little slow.
Oh my goodness.
I think we have a number of output files. Let's see what they look like. Alright, that's not the prettiest file I've ever seen in my entire life, but it looks like we picked it off for Ben Hill Middle, picked off all the information, created a separate one. So I actually ran this program, created my 197 files, uploaded it to the website, and the PTA is thrilled beyond belief. Because now they have individual invoices for each one of those schools who have been able to put it on their website.
So whenever they want to change it, all they have to do is put the file.
Each year, they'll just have to run my Python program and punch it out.
And you've got a job.
Fantastic! Let's look at your toolbox one last time, shall we? Look, we've been able to add modules. Now you have the ability to reach outside of your program and grab code that other people have produced and put it into yours. Finally, you have a complete Python toolbox. We did modules, we did refactoring, and we did real-world Python programming problems. Whatever shall we do next time? There is only one answer to this question. Presentation.
Yes.
In-class presentation. Fantastic. Wonderful. Have a great weekend. I look forward to your presentations starting next week.